And today we are going to learn about linear programming and how we can take what we just learned in the last lesson about linear inequalities and systems of linear inequalities to the next level. Before we get started with today's lesson, I would like you to please solve the following system. It reads 2x plus 3y equals 9 and negative 3x plus y is equal to 25. I would like you to please pause the video and solve the system, and when you have an answer, please restart the video and we will see how well you did. Okay, there are multiple ways to approach this problem. You could either work with substitution or elimination. It just depends on what you like to work with. So I'm going to recognize that in this problem, I have a variable that has a coefficient of 1. So that means I'm going to work with substitution. So I'm going to start off this problem by solving the second equation for y. I'm going to add 3x to both sides and end up with y is equal to 3x plus 25. I'm going to substitute 3x plus 25 in for y into the first equation, and then I'm going to solve for x. So I'm going to write 2x plus 3 times 3x plus 25 equals 9. So I'm going to write 2x plus 9x plus 75 equals 9. Combining my like terms, I end up with 11x plus 75 is equal to 9. Subtracting 75 on both sides, I find that 11x is equal to negative 66, and dividing both sides by 11, x is equal to negative 6. Cool. So I found that x is equal to negative 6, and now I need to find my y value. So I'm going to substitute negative 6 into my revised equation from step number 1, which is y equals 3x plus 25. So I'm going to write that y is equal to 3 times negative 6 plus 25, which is y equals negative 18 plus 25, and negative 18 plus 25 is equal to 7. So negative 6, 7 is my solution to this system. This system would be called consistent and independent. So making sure that you study and really remember what those terms are is going to be very important, especially when you are preparing for your test. Also, knowing how to solve a system of equations, that skill is foundational for this lesson for today. So our learning objectives for using linear programming is for you to be able to say, I can create and graph constraints, which constraints are going to be inequalities. I can create and graph constraints to solve real-world problems and find the maximum and minimum profit of a business. So what we are going to do in this lesson is we are going to actually apply systems of linear inequalities to a real-world situation that people are actually using today in the workforce. Linear programming is probably one of the most useful tools of algebra. It helps businesses decide how much of a product they need to produce, given the fact that they only have so many resources, so much time in a day in order for them to complete a project or complete a product. So let's consider the following situation. It says, a potter wants to make and sell serving bowls and plates. A bowl uses 5 pounds of clay, and a plate uses 4 pounds of clay. The potter has 40 pounds of clay and wants to make at least 4 bowls. So the question says, or the next phrase says, let x equal the number of bowls made, since that's something that we do not know, and let y equal the number of plates made. So one of the first things that you're going to do in these types of problems is you're going to need to actually identify what x and y represent. And in this problem, it's already done for you. But when we get into later problems, I'm going to actually ask you to lay out what each variable represents. Next, it says you could represent the information using linear inequalities that we're going to call constraints. So we're going to let x equal the number of bowls made, let y equal the number of plates made, but we only have some certain information. So I'm going to go back and reread this problem to list out my constraints. It says a potter wants to make and sell serving bowls and plates. A bowl uses 5 pounds of clay and a plate uses 4 pounds of clay. The potter has 40 pounds of clay to use and wants to make at least 4 bowls. Now, in terms of bowls, at least 4 bowls means that our number of bowls needs to be greater than or equal to 4. That's a constraint. We cannot have our bowls be 3, 2, or 1. It needs to be 4 or bigger. But with respect to plates, we don't have a constraint on plates. We can make anywhere from 0 plates to however many plates 40 pounds of clay can produce. But there does exist a constraint. You cannot make negative plates. So that means that our plate, which is y, needs to be greater than or equal to 0. So our bowls needs to be greater than or equal to 4, meaning that we need to make at least 4 bowls. And our plates, well, we can't have negative plates made. That needs to be greater than or equal to 0. There's one more constraint, and that is the amount of clay that we have. We don't have an infinite amount of clay. This potter doesn't have an infinite amount of clay. He has 40 pounds. And each time that he makes a bowl, he uses 5 pounds of that 40. And every time he makes a plate, he uses 4 pounds of the 40. So with respect to the constraints, 5 times x, that means 5 pounds per bowl, plus 4 times y, which means 4 pounds per plate, needs to be less than or equal to 40 pounds. We only have 40 pounds, so that's the at most. At most, 40 pounds can be used. Those are our 3 constraints. So the constraints are inequalities that represent the situation. And notice that in this problem, I'm not going very fast. I'm analyzing each piece and rereading this problem over and over again to gain an understanding of what the problem is asking. Now, the potter's total profit is given by an equation, and I'm going to give you this equation is P equals 35x plus 30y. And this is called the objective function or the profit function. And that's what the P represents. It represents profit. And what this 35 and 30 represent is it represents that he's going to make $35 or sell each bowl for $35 and then sell each plate for $30 and make a profit, and that would be his profit on it. It then says it would be reasonable for the potter to want to maximize his profit subject to the given constraints. This process of maximizing or minimizing a linear, this word is linear, a linear objective function is subject to constraints that are linear inequalities. This is called linear programming. So linear programming is where you take a set of constraints that we identify and work with an objective function to identify the maximum profit or the minimum profit. Now, if all of the constraints are graphed on one grid, all of the points in the intersection are the combinations of bowls and plates the potter can actually make. The intersection of the graph is called the feasible region. So the intersection I'm talking about, that is the fully shaded region where all of the inequalities come together and create a region that is completely shaded, where all of the colors meet together. Now, if the feasible region for a linear programming problem is bounded, and bounded looks like this first picture right here, then the objective function has both a maximum value and a minimum value. Moreover, those maximum values and minimum values occur at the vertex of the feasible region. So what you're going to do is you're going to identify each vertex, and you're going to substitute the ordered pairs of each vertex, of each corner point, into the profit function. And whatever values turn out to be the largest, or whatever ordered pairs produce the largest number, that's your maximum profit. And whatever ordered pairs produce the smallest number, that's going to represent your minimum profit. So in these problems, we're not going to be working with unbounded regions. For our class, we're going to only be working in the realm of bounded regions. And what I'm going to ask you to do is I'm going to ask you to check and identify all corner points, all vertices. And this is to find your maximum or minimum profit. Let's turn the page. All right, in example number 1, we're going to continue with this problem. It says, how many bowls and how many plates should the potter make in order to maximize profit? So we have the constraints that we had on page 1. Our constraints were x needs to be greater than or equal to 4, y is greater than or equal to 0, and 5x plus 4y needs to be less than or equal to 40. So step number 1 is to graph all of these inequalities. So I'm going to use a pencil because I'm going to be erasing and I want to identify my fully shaded region. I know that x is greater than or equal to 4 is a VUX, a vertical line, undefined slope. X equals a number. So I'm going to go to where x equals 4 and I'm going to draw a vertical line. And it's going to be a solid line. And I want to shade all values of x greater than or equal to 4, and that's going to be to the right. And I'm going to shade very, very lightly because I will be erasing. Next, I have y is greater than or equal to 0. This is a HOI. And so I'm going to go to where y is equal to 0, and I'm going to draw a horizontal line going straight across. And I want all values of y greater than or equal to 0. So I'm not going to shade on this side. I'm only going to shade the region that has the overlap. But I'm still going to only shade lightly because I still have one more function to graph. Now I have 5x plus 4y is less than or equal to 40. You can work with the intercepts, or you can change it to y equals mx plus b. It just depends on what you want to do. I'm going to change it to y equals mx plus b. So I have 5x plus 4y is less than or equal to 40. And I'm going to subtract 5x on both sides. And I end up with 4y is less than or equal to negative 5x plus 40. Dividing every single term by 4, I end up with y is less than or equal to negative 5/4 x plus 10. So I'm going to go up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to plot a point, and I'm going to go down 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, over 4. 1, 2, 3, 4. And I'm going to plot that point and come up with as many points as you can because those points might end up as a corner point. So I'm going to go down 5 again, 1, 2, 3, 4, 5, and over 4, 1, 2, 3, 4, and I'm going to plot a point. And I'm going to draw a line going through those points. This is a solid line again because I have an equal to sign. And I'm going to check. I'm going to check an ordered pair that's easy, just like we did in the last lesson. And I'm going to check 0, 0. And I'm going to see, is 5 times 0 plus 4 times 0 less than or equal to 40? Is 0 less than or equal to 40? Why, yes, it is. So I'm only going to be shading below this graph. And I only want to shade actually the region that is below that's already been shaded. And that is just this region right here. If I were to shade all of it, yeah, it would be less than. But I'm only interested in the bounded region, and that is this region right here. So I'm going to erase everything else that is not part of the triple shaded region so that I can actually focus on the information that I'm interested in. and that is this triangle shape. And I would recommend that you really emphasize your corner points. And in this case, we have 3 corner points. And I'm going to label these corner points A, B, and C. I'm going to be looking for you to label those points when you're actually doing these problems. So now I'm going to test the corner points into my profit function. So point A, this is located at 1, 2, 3, 4. So that's located at 4, 0. And I'm going to plug 4, 0. Let me zoom this over here. I'm going to plug 4, 0 into my profit function. So I'm going to say P equals 35 times 4 plus 30 times 0. What does that equal? That equals $140. So this means that if my potter were to make 4 bowls and 0 plates, he would make a profit of $140. Let's look at letter B. Letter B's ordered pair. That's located at 4, 1, 2, 3, 4, 5. 4, 5. Its profit would be 35 times 4 plus 30 times 5. 35 times 4 plus 30 times 5, just plug that into your calculator, you'll end up with $290. So far, $290 appears to be our maximum so far. But now we need to check letter C. And letter C is located at 1, 2, 3, 4, 5, 6, 7, 8, 0. And my profit is going to be 35 times 8 plus 30 times 0. 35 times 8, that's equal to 280. So my maximum profit is going to be $290. And that happens when the potter makes 4 bowls and 5 plates. So that's what our statement is going to be. So on the side, I'm going to say that the potter will make a maximum profit of $290 if he makes 4 bowls and 5 plates. And that is the end of that problem. So the whole point, what we need to do for this problem is you graph your constraints. That's step number 1. Step number 2 is you need to identify your corner points. So I'm going to put a little 2 right here. I'm going to identify my corner points. I labeled them as well. It's very important that you label everything and keep yourself organized. Step number 3 is you need to substitute those ordered pairs into your profit function. Then you need to identify your maximum or minimum depending on what the question is asking of you. In this case, we identified the largest number is 290. And then you need to make sense of the problem by writing it in a statement. So this is step number 4. The potter will make a maximum profit of $290 if he makes 4 bowls and 5 plates. This is what you're going to see on your test. It'll be structured where I'm going to ask you to list all of your information and then give me a final answer statement. So let's go ahead and look at example number 2. This type of problem does not have any context to it. It's simply asking you to find the maximum and minimum value of the objective function c is equal to 3x plus 4y subject to the following constraints. Now I want you to know that when it comes to the objective function, you don't graph it. You just use it to identify maximum and minimum values. You do not graph the objective function. So looking at x is greater than or equal to 0, that is a VUX situation. So I'm going to graph that. I'm going to go to where x is equal to 0, and I'm going to draw a vertical line, and I'm just going to lightly shade. So everything is shaded to the right. And then I'm going to go to where y is equal to 0, and I'm going to draw a horizontal line because this is a HOI situation. And I want all values of y greater than or equal to 0, so I'm just going to shade just above. So everything's already shaded, and I'm going to just shade very lightly. Next, we have x minus 3y is greater than or equal to negative 12. I'm going to change that to y equals mx plus b. So I'm going to write x minus 3y is greater than or equal to negative 12. And I'm going to change it to y equals mx plus b by solving for y. So I'm going to subtract x on both sides. I end up with negative 3y is greater than or equal to negative x minus 12. I'm going to divide every single term by a negative 3, and whenever you divide both sides of an inequality by a negative number, you flip the direction of the inequality, and this becomes y is less than 1/3 x plus 4. So I'm going to go to where y is equal to 4. So up to 4, 1, 2, 3, 4. And then I'm going to rise 1 and run forward 3. And I would recommend coming up with as many points as you can on this line so that because any of these points could end up being a corner point. So I'm going to rise 1 and run forward 3. And I'm going to keep going until I can't keep going anymore. So those are all of my points, and I'm going to draw a solid line going through them. And then I'm going to decide what my shaded region is going to be. So I'm going to check in this problem 0, 0, because 0, 0 is down here and it's not on the line. And I'm going to see, is 0 minus 3 times 0 greater than or equal to negative 12? Is 0 greater than or equal to negative 12? It is. So that indicates that I'm going to shade below. So I'm just going to shade everything below. And anything that's above will be erased, which is why we shade very, very lightly. Next, I have 3x plus y is less than or equal to 24. And I'm going to rewrite it over here, and I'm going to solve for y. 3x plus y is less than or equal to 24. Subtracting 3x on both sides, we end up with y is less than or equal to negative 3x plus 24. Whoa. 24 is kind of high, kind of a large number. So maybe what I should do instead is maybe I should work with the intercepts. I can see that my slope is going to be negative 3, but that's way too tall. Like I can't plot that. So maybe that's not the best approach. Maybe instead I should work with the intercepts. And that's why I have encouraged you guys to be open to both ways. So I'm going to rewrite this problem of 3x plus y is less than or equal to 24. Clearly, I know that the y-intercept is located at 0, 24, and that is way too tall. So instead, I'm going to identify my x-intercept by letting y equal 0. So I'm going to let y equal 0. That gives me 3x is, and I'm going to call it equal to because I want to identify my x-intercept, equals 24. And dividing both sides by 3, I end up with x is equal to 8. So I'm going to plot the ordered pair 8, 0. Because that point is actually going to be on my line. So I'm going to go to where 8, 0 is. 1, 2, 3, 4, 5, 6, 7, 8. And my slope is negative 3. So I have m is equal to negative 3. So with my slope being negative 3, I'm going to start at 8, 0. And I'm going to rise 3 and run backwards 1 so that I end up with a negative slope. So I'm going to rise 3 and run backwards 1, and I'm going to rise 3 again and run backwards 1, rise 3 again and run backwards 1 until I can't do it anymore. And I'm going to draw a line going through all of these points. So now I need to test a point to see which one will work. So I'm going to test 0, 0 into my original problem. 0, 0 is not on this line, so I'm going to write is 3 times 0 plus 0 less than or equal to 24. Yeah, 0 is less than or equal to 24. Cool. So that means that I'm going to shade on the side that has the 0, 0. And I'm only interested in the region that has already been shaded. So I'm just going to shade below. That means that this piece over here, I'm not interested in it. So I'm going to erase it. And now I have my feasible region. So now that I've shaded everything, I need to identify my corner points. And we have, in this case, 4 corner points. So I would recommend that you label them A, B, C, and D. and write all of those ordered points or ordered pairs down. And we're going to check them into the objective function. So A is located at 0, 0. And I'm going to plug 0, 0 into my objective function. So this is C equals 3 times 0 plus 4 times 0, and that equals 0. Chances are this is our minimum value. So our minimum in this case is going to be 0, 0. But now we need to identify our maximum. So my maximum in this case, well, I'm not sure if it's going to be at B, C, or D. We can make a guess, but we need to make sure that we verify that. Okay, letter B is located at 1, 2, 3, 4, 0. So 0, 4. So I'm going to write down 0, 4. And I'm going to say, what's C? C is equal to 3 times 4 plus 4 times 0, and that is going to be equal to 12. Okay, let's look at C. C is located at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6. And that is C equals 3 times 6 plus 4 times 6. So that is 18 plus 24, and 18 plus 24, that is equal to 42. All right, so far I can see that B is not going to be my maximum. Maybe C will be. So now we're going to check D. And D is located at 1, 2, 3, 4, 5, 6, 7, 8, 0. And so I have C is equal to 3 times 8 plus 4 times 0, and that's going to be equal to 24. So in this case, letter C is going to be my maximum value. And the maximum value in this case is going to be 42. And my minimum in this case is 0. And that's located at 0, 0. All right, let's go ahead and look at example number 3. This one actually has context, and I'm going to put stars all around it because this is the type of problem that you're going to see on your test. So please pay attention to what I do for number 3. It reads, piñatas are made to sell at a craft fair. It takes 2 hours to make a mini piñata and 3 hours to make a regular size piñata. The owner of the craft booth will make a profit of $12 for each mini piñata sold and $24 for each regular piñata sold. The craft booth owner has no more than 30 hours available to make piñatas and wants to make at least 12 piñatas to sell. It doesn't matter if those piñatas are mini or if they're regular. So we need to write an objective function to represent the maximum profit that the owner can make. So let's go back and reread this and identify some constraints and label our variables. So we need to know what we're going to let x equal. We need to know what we're going to let y equal before we even make our objective function. So it says piñatas are made to sell at a craft fair. It takes 2 hours to make a mini piñata and 3 hours to make a regular size piñata. The owner of the craft booth will make a profit of $12 for each mini and $24 for each regular. The craft booth owner has no more than 30 hours to make piñatas and wants to sell at least 12 piñatas. Okay. We don't know how many of each type of piñata this craft booth owner is going to make. So that is what our unknown is. How many of each will this person need to sell in order to maximize profit? So my x values are going to represent the number of mini piñatas and y is going to represent the number of regular piñatas. And my profit function is going to be based on money. So my profit function, we always say, is P equals. And my profit function in this case is this person will make a profit of $12 for each mini. So that's 12 times x plus this person will make $24 for each regular size. So that's plus 24y. And that is our profit function, our objective function. Remember that objective functions are not something that you graph. It's something that you use to identify the maximum or minimum after you've graphed your constraints. So now we're on to constraints. The first thing that we need to talk about is what is the minimum number of each type of piñata that this person can make? Well, it doesn't say. It doesn't say that they want to make at least this type of piñata. Like, we don't have at least 4 mini piñatas or anything like that labeled. So it is possible for this person to make 0 mini or 0 regular. So I'm going to list my first 2 constraints as x needs to be greater than or equal to 0 and y needs to be greater than or equal to 0. Those are my first 2 constraints. That means that you cannot have negative piñatas, and you're allowed to have 0 if you choose. Next, our other constraint that we have is time. This craft booth owner has no more than 30 hours available to make each, and it requires 2 hours, he requires or she requires 2 hours to make a mini piñata and 3 hours to make a regular sized. So with respect to time, 2 hours per each, or for each mini, plus 3 hours for each regular can't be greater than 30 hours. It needs to be less than or equal to 30 hours. You can't spend any more time than 30 hours. That's all you have. And then on top of that, this person wants to make at least 12 piñatas to sell. So that means your total of mini plus your total of regular needs to be greater than or equal to 12 piñatas. It needs to be more than 12. You can't sell 11 or 10. It needs to be bigger. So those are our constraints, and we're going to graph those constraints on our grid. So the easy ones are x is greater than or equal to 0 and y is greater than or equal to 0. So I'm going to draw a vertical line at x is equal to 0, and it's going to be a solid line. And I know that everything is essentially going to be shaded. Essentially. And then I'm going to graph my HOI, which is my horizontal line. And I know that shading, everything needs to be greater than or equal to y, and that means once then everything is going to be shaded. So you don't have to shade anything quite yet because the whole grid is shaded. So now I'm going to graph 2x plus 3y is less than or equal to 30. And I'm going to change this to y equals mx plus b by subtracting 2x on both sides, and I end up with 3y is less than or equal to negative 2x plus 30. Dividing every single term by 3, I find that y needs to be less than or equal to negative 2/3 x plus 10. So I'm going to go up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to plot a point. And then from here I'm going to go down 2 and to the right 3. And I'm going to plot as many points as I can on this line. And the reason why I do that is because any of these points could be considered a corner point. So the more points that you have, the more accurate your graph will be, and the easier it is to identify your vertices, your corner points. Now I'm going to identify my shaded region by using a test point. And I'm going to say is 2 times 0 plus 3 times 0 less than or equal to 30. So what I'm doing is I'm testing 0, 0. Because 0, 0 is not on this line. And is 0 less than or equal to 30? It is. So that means I'm going to be shading below. And I'm still going to shade lightly, and anything else that I shaded above is going to be erased, because I'm not going to use it. It's not going to be a part of my shaded region, but I'm still only going to shade it very lightly. Next, I have x plus y is greater than or equal to 12. And so I'm going to bring x to the other side to make this y is greater than or equal to negative x plus 12. So I'm going to go up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to apply my slope, which is negative 1. Down 1 to the right 1. I'm going to plot as many points as I can because, like I said, you never know which point is going to be a corner point. right, let's go ahead and look at this. I'm going to graph this line. It's going to be a solid line again. And now I need to use a test point. And I'm going to once again test 0, 0. And I'm going to see, is 0 plus 0, use pen, 0 plus 0 greater than or equal to 12? 0 is not greater than or equal to 12. So that means I'm not going to shade on this side of the graph. Instead, I'm going to shade above. And shading above this line, well, it's going to be up here. But the part that is the overlap is this really, really, really tiny triangle. Shading above this line is going to be everything over here, but I'm only interested in the overlap, so that's just this location, indicating that I'm going to erase all of the other parts. So that's where it's really important to identify your corner point. So it appears as if this point right here, where these lines intersect, that's going to be a corner point. So I'm going to call that A, here is B, and I'm going to call this C. So letter A, we identified our objective function and identified what x and y represent. Letter B, I listed our constraints and graphed them. Letter C, listed our constraints, and letter C is we graphed them, labeling the graph. Letter D says label each vertex in the feasible region. We just said that, A, B, C. And letter E says how many of each type of piñata should the owner make in order to maximize profit. So this is where we identify our ordered pairs and plug them into our objective function. So letter A appears to be located at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It looks like it's located at 6, 6. So I'm going to write P is equal to 12 times 6 plus 24 times 6. 12 times 6 plus 24 times 6, that is equal to $216. And what I'm using is this profit function from right back here at letter A. Letter B, we have the ordered pair 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is located at 12, 0. I'm checking my profit. This is going to be at 12 times 12 plus 24 times 0. This is equal to 144. So far letter A is winning. And now we're at letter C. C is located at, if this is 12, we have 13, 14, 15, 0. So my profit's going to be located at 12 times 15 plus 24 times 0, and that is equal to 180. So our maximum profit is going to be located right here at 216. So I'm going to write a statement. The craft booth owner will make a maximum profit of $216 only if the owner makes 6 mini and 6 regular piñatas. And that is your answer, as well as the end of this video. I recognize that linear programming is a lot, and we're going to be spending a couple of days in order to truly understand this concept and practice this concept in greater detail. Please feel free to email me if you have any questions over anything. Otherwise, hope you have a wonderful day.